If you want to understand the greatest engineering mysteries of the ancient world, you don't need to look at a pyramid or a megalith. You just need to look at your kitchen floor. Think about the last time you tried to move a heavy appliance, like a refrigerator or a washing machine, by yourself. You didn't pick it up. You didn't even really slide it. Instead, you tilted it slightly to one side, pivoted it on a single corner, and then rocked it back to the other side. You walked it. It is a quiet, mundane little trick of physics that allows a single human being to move hundreds of pounds without a crane or a forklift. This tiny everyday observation is actually the secret key to how our ancestors moved the world. It is the bridge between your Sunday afternoon chores and the construction of monuments that have outlasted every empire that tried to claim them. We live in a world of hydraulics and internal combustion, so we assume that moving a 50-ton block of granite requires a miracle or a visitor from another planet. We see a massive stone, and we think of it as a dead, immovable weight. But the people who built the ancient world didn't see stones that way. They saw them as objects governed by leverage, friction, and center of mass. Variables they could manipulate with nothing more than wood, water, and rope. They didn't have machines because they didn't need them. They understood a paradox that we have largely forgotten. The heavier an object is, the more it wants to help you move it, provided you know where to push. This isn't a story about primitive people doing the impossible through sheer, grinding misery. It is a story about the most sophisticated physicists to ever live, who used the Earth's own laws to turn mountains into architecture. The math doesn't lie. The first thing we have to dismantle is the most persistent myth in all of history. The idea that the great monuments of antiquity were built by hundreds of thousands of exhausted slaves driven by the whip. For decades, this was the standard Hollywood image of ancient Egypt or Mesopotamia. It's a compelling drama, but it's a logistical nightmare that doesn't actually work. If you have 50,000 people all pulling on a single rope, they don't move a stone. They just get in each other's way. You cannot feed, house, or organize a slave force of that size without the entire project collapsing under its own weight within a month. The reality is much more interesting and was confirmed in 2013 by a team led by archaeologist Pierre Tallet. They discovered the Diary of Merer in a cave at the ancient Red Sea port of Wadi al-Jarf. These are the oldest papyri ever found, and they are essentially the spreadsheets of the Great Pyramid's construction. Merer was a middle manager, a foreman in charge of a crew of about 40 elite workers. His logs don't describe a reign of terror. They describe a high-stakes, high-precision logistics operation. They detail how his crew transported limestone blocks from the Tura quarry to Giza by boat, utilizing the seasonal flooding of the Nile to get the stones as close to the construction site as possible. These weren't slaves. They were well-fed, highly skilled contractors. Archaeological digs at the workers' village in Giza have uncovered the remains of cattle, sheep, and goats in quantities that suggest the builders were eating better than the average Egyptian citizen. They were organized into competing teams with names like the Friends of Khufu or the Drunkards of Menkaure. They weren't being forced to build a tomb. They were participating in a national engineering project that functioned more like a modern space program than a forced labor camp. Brute force is a myth. If you aren't using millions of people to drag a stone, you have to deal with the primary enemy of all ancient builders: friction. When you try to drag a multi-ton limestone block across dry sand, the sand bunches up in front of the stone, creating a mound that makes the weight exponentially harder to move. For a long time, historians looked at ancient wall paintings, specifically one from the tomb of Jehuti-Hotep, dating back to 1900 BC, and saw a curious detail. It shows a massive statue being pulled on a sledge, and there is a man standing on the front of the sledge pouring water onto the sand. For years, scholars thought this was a ritualistic gesture, perhaps a way of purifying the path. But in 2014, a team of physicists from the University of Amsterdam, led by Professor Daniel Bohn, decided to test this ritual in a lab. They discovered that if you add just the right amount of water to sand, you create what are called capillary bridges. These are tiny droplets of water that bind the sand grains together, making the sand twice as stiff as dry sand. Instead of the sand bunching up into a wall in front of the sledge, it becomes a smooth, hard surface. This simple trick reduces the required pulling force by a staggering 50%. The ancient Egyptians weren't just pouring water, they were performing advanced fluid dynamics. They had figured out the exact ratio of water to sand, usually between 2 and 5% of the sand's volume, to turn a desert into a highway. This is why they could move stones weighing 10 or 20 tons with relatively small teams of men. They weren't fighting the environment, they were hacking it. Gravity is actually a tool. Once the stone arrives at the site, the problem shifts from horizontal movement to vertical lifting. This is where the Great Pyramid of Giza usually triggers the most alien theories because the sheer scale seems impossible. We are talking about 2.3 million blocks, some of them granite beams weighing 80 tons, lifted nearly 500 feet into the air. The traditional theory of a single massive external ramp has been mathematically debunked. To build a ramp that reached the top of the pyramid at a slope shallow enough for men to pull stones up it, you would need more material than was used in the pyramid itself. It would have been a second larger monument just to build the first one. This is why the work of French architect Jean-Pierre Houdin is so revolutionary. He spent years using advanced 3D modeling software, the same kind used to design cars and airplanes, to look for a hidden solution. He proposed that the Egyptians used a two-part system. For the bottom third of the pyramid, they used a standard external ramp, but for the rest, they built a spiraling internal ramp inside the structure itself. In 2008, a team of researchers using microgravimetry, a technique that measures the density of the stones, detected a spiral shape of lower density material winding its way up the interior of the pyramid. Houdin's theory also solved the mystery of the Grand Gallery, a massive vaulted hall inside the pyramid. He argued it wasn't just a hallway, but a giant internal track for a counterweight system. By using a heavy weight sliding down the gallery, the builders could use gravity to help pull the massive granite blocks up the ramp. It was a giant stone machine. They weren't lifting the stones against gravity. They were using the weight of one stone to lift another. The island tells a different story. If the Egyptians were masters of the ramp and the sledge, the people of Rapa Nui, Easter Island, were the masters of the pivot. There are nearly 900 Moi statues on the island, some of them 30 feet tall and weighing 80 tons. For a century, Western researchers assumed the islanders must have moved them horizontally on log rollers. The problem was that the island didn't have enough trees to support that kind of operation, and the roads on the island were curved and hilly, which would have made log rollers nearly impossible to use. The islanders themselves had a very simple explanation for how the statues reached their platforms. They said the statues walked. In 2012, anthropologists Carl Lipo and Terry Hunt decided to stop assuming the islanders were speaking in metaphors. They noticed that the moai found in the quarry had a very specific shape. They had heavy, D-shaped bases and were designed with a forward-leaning center of gravity. When Lipo and Hunt built a 5-ton replica moai, they found that by attaching 3 ropes, one to the back and one to each side, a team of just 18 people could rock the statue from side to side. Because of the D-shaped base and the forward lean, every time the statue rocked, it took a step forward. It looked exactly like a person walking a heavy refrigerator across a room. This method was so efficient that the statues practically moved themselves once the rhythm was established. The walking theory explained why the statues found abandoned along the roads were always on their bellies if they were going uphill, or on their backs if they were going downhill. They hadn't fallen off rollers. They had lost their balance while walking. This was a culture that didn't have the wheel, yet they moved 80-ton monoliths miles across rugged volcanic terrain by treating stone as a living, moving weight. But the math gets weirder. In southern England, Stonehenge presents a different puzzle. While the Egyptians had a massive central state and the Rapa Nui had a highly specialized social hierarchy, the Neolithic people who built Stonehenge were working with far fewer resources. The bluestones of Stonehenge were transported from the Priestley Hills in Wales, a distance of over 140 miles. Some of these stones weigh 4 tons. Moving them required crossing water and dense forest. While many researchers have focused on rafts, a fascinating 2010 study by the University of Exeter suggested a ball-bearing system. They found carved stone balls at various Neolithic sites and realized that if you placed these balls into wooden tracks, you could move massive loads with almost zero friction. By placing a heavy stone on a wooden platform that sat on these stone spheres, a small group of people could push a multi-ton block with one hand. It is the same principle used in modern aerospace engineering to move heavy equipment. The builders of Stonehenge weren't just dragging rocks. They were experimenting with rolling elements and specialized tracks. They were reducing the physical cost of movement until it was almost negligible. Every culture, it seems, found its own unique way to cheat the laws of physics. Whether it was the wetted sand of Egypt, the walking statues of Rapa Nui, or the stone bearings of Britain, the goal was always the same. Find the point where the weight of the object becomes an asset rather than a liability. Prevesion was the real miracle. We often focus on the movement, but we forget the shaping. At the Barabar caves in India, carved around 300 BC, the interior walls of the granite caves are polished to a mirror finish that is so precise it creates a mathematical echo. At Sacsayhuaman in Peru, the stones are so tightly fitted together that you cannot slide a piece of paper between them, despite the stones being irregular, multi-angled shapes. This level of precision is often cited as proof of lost technology or laser cutting tools, but experimental archaeology has shown that you don't need lasers, you just need sand and time. Granite is incredibly hard, but it can be cut and polished using copper saws and abrasive sand. The sand does the actual cutting. The copper just holds the sand in place. To get the perfect fit seen in Inca masonry, researchers believe they used a method of scribing, where the shape of one stone is carefully traced onto the next. They would then use pounding stones, harder rocks used as hammers, to slowly chip away at the surface until the fit was perfect. It is a slow, meditative process. The miracle isn't the tool, it's the patience. Modern construction is about speed. Ancient construction was about permanence. We use fast materials like concrete and steel that begin to degrade within a century. They used slow materials like granite and diorite that last for millennia. They didn't have to worry about a quarterly budget or a 4-year political cycle. They could afford to spend 20 years polishing a single room because they were building for eternity. The logic remains the same. The real big reveal of ancient engineering isn't a secret machine or a forgotten power source. The reveal is that ancient humans viewed the world through the lens of logistics rather than energy. In the modern world, if we want to move something, we add more power. We build a bigger engine, we burn more fuel, we use more electricity, we solve problems with force. Ancient humans didn't have an external power source, so they had to solve problems with geometry. They looked at a massive stone and asked, how can I make this weight lift itself? They looked at the sand and asked, how can I make this act like water? They looked at the river and asked, how can I make this act like a conveyor belt? Their technology was a deep, intuitive understanding of the natural world that we have largely lost. We think we are more advanced because we have computers, but our ancestors were performing complex structural engineering and orbital mechanics in their heads. They aligned the pyramids to true north with an accuracy of within 3/60ths of a degree, a feat that is difficult to achieve even with modern GPS. They weren't primitive people trying to be like us. They were a different kind of human altogether, people who were more connected to the physical realities of the earth than we will ever be. They didn't see the environment as a resource to be conquered. They saw it as a set of rules to be played. Friction is never truly gone. Think about the sheer amount of information that had to be passed down through generations to keep these projects going. Great Pyramid took 20 years to build. That is an entire generation of workers who were born, trained, and died on a single construction site. This requires a level of social stability that we can barely imagine. To build like the ancients, you don't just need ropes and ramps. You need a culture that believes in something enough to work on it for decades without stopping. You need a language of measurement that stays consistent for centuries. You need a supply chain that never breaks. When we look at these monuments, we are looking at the physical manifestation of a perfectly functioning society. The moment the society begins to fracture, the stones stop moving. You can see this in the quarries of Rapa Nui or the unfinished obelisk in Aswan. There are massive projects that were simply abandoned in the middle of a workday because the social machine that supported them finally broke down. The stones are still there, half-carved, waiting for a crew that will never return. It is a haunting reminder that the most impressive part of ancient engineering wasn't the stones themselves, but the human machine that moved them. Once that machine is gone, the physics are still there, but the will to use them vanishes. The truth is hiding in plain sight. We have spent centuries looking for the secret of the ancients, hoping to find some magical shortcut that would explain how they did it. We wanted to find evidence of anti-gravity, or sound-based levitation, or advanced machinery that has since rusted away into nothing. But the answer is actually much more impressive than any of those theories. The secret was simply the absolute mastery of the obvious. They used the things that are for free: gravity, friction, water, and time. They realized that a lever can move the world if the lever is long enough. They realized that a stone can walk if you rock it just right. They realized that a river is a gift from the physics gods. We find this hard to believe because we are addicted to complexity. We think that if a problem is big, the solution must be complicated. But the ancient world was built on the power of the simple. It was built by people who looked at a mountain and didn't see an obstacle, but a puzzle. They understood that the laws of physics are not a prison, they are a set of tools. And they used those tools to build a world that is still standing while ours is already starting to crack. But here is the most uncomfortable part. We like to think of ourselves as the pinnacle of human achievement. We have smartphones, we have satellites, and we have the internet. But if our civilization ended tomorrow, what would be left of us in 5,000 years? Our steel buildings would be piles of rust. Our concrete would be dust. Our digital records would be gone the moment the power grid failed. The only thing that would remain are the things we didn't build, the mountains and the oceans. But if you went to Egypt, or Easter Island, or Stonehenge, you would still see the work of the people who came before us. Their primitive technology has a shelf life that our advanced technology cannot even fathom. They didn't just build structures, they built a legacy that is literally carved into the crust of the planet. They proved that if you understand the fundamental laws of the universe, you don't need a motor to move the world. You just need to know where to stand. They were the ultimate engineers because they achieved the maximum result with the minimum possible tools. They turned the mundane into the miraculous. And they did it all by paying attention to the same simple physics that you use every time you move a piece of furniture across your living room floor. The distance between us and them is a total illusion. Every time we look at these monuments and say, it's a mystery, we are doing a disservice to the people who built them. It's not a mystery, it's an achievement. Calling it a mystery is our way of coping with the fact that we might not be as smart as we think we are. We want to believe there was a trick because the alternative is much more demanding. The idea that we could do the same thing if we were just willing to be as patient, as organized, and as observant as they were. We are surrounded by the same physics they were. We have the same hands, the same brains, and the same gravity. The only thing we lack is their perspective. They didn't see themselves as separate from nature. They saw themselves as a part of its mechanics. They were the pivot point. They were the counterweight. They were the fluid dynamic. They didn't just live in the world, they operated it. And that is the most important lesson they left behind. The world isn't something that happens to you. It is something you can move, one patient, rocking step at a time. You probably think you're living in the most advanced age in human history because you can order a pizza with your thumb. But the truth is, if the power went out tonight, you wouldn't even know how to move a large rock out of your own driveway without calling someone with a machine. We have outsourced our understanding of the physical world to engines and algorithms, while the people who built the pyramids carried the entire library of physics in their calloused hands. They didn't need a manual because they were the ones who wrote the laws of the landscape. We spend our lives surrounded by things that are designed to break, while they spent theirs building things that were designed to never, ever move again. It's a strange realization to have while sitting in a house made of drywall and 2x4s that won't last a century. We aren't the ones who figured out how the world works. We're just the ones who figured out how to stop paying attention to it. The ancient builders don't need you to solve their mystery because they already finished the work and left the receipts in the stone. They didn't have magic and they didn't have aliens. They just had a better grip on reality than you do.